whatever questions we can. So we can see that the domain is going to be negative infinity to infinity, right? The x's keep going forever. My range is going to be negative infinity up to positive 1. Please don't write it as 1 to negative infinity, okay? I'll do this in black here. So I want you to see this does not go down. You don't start at 1. Remember, I always told you you have to start up. So you rise from the bottom, just like, you know, when you get a job someday, you're going to rise to the top. So you start at the bottom and you work your way up. So we're going from negative infinity to positive 1. Okay, my x and y intercepts, so x equal to 0, y equal to 0. So let's do this one first. So if I set this guy equal to 0, 0 equals negative 4x, minus 3 squared plus 1. Okay, so order of operations backwards. So negative, I'm going to subtract 1 equals negative 4x minus 3 squared. Divide by negative 4, so I get negative 1 over negative 4 equals x minus 3 squared. So this is positive a fourth equals x minus 3 squared. And now I can take the square root, right? Square root of both sides, positive and negative, positive and negative. So this is the square root of 1 over the square root of 4. Remember, you can split up a square root like that. So this, what is square root of 1? Well, that's 1, and square root of 4 is 2, equals just x minus 3. But remember, this is positive and negative. I've got two halves there. I've got a positive a half and a negative a half. So now I add 3 to both sides. So if I add 3, I like to put it out front, so I'm going to have 3 plus or minus 1/2 equals x. So I'm going to get 3.5 equals x, and I'm going to get 2.5 equals x. But in this class, we list them as points, 3.5, 0, and 2.5, 0. So those are my x-intercepts. So if I look at my graph, that seems about right. So this actually would be enough information for you to graph this accurately. Because so let me do this a little more carefully. So if I start at 3, 1, oops. If I go 2.5 and 3.5 and plot those two intercepts, don't you think 3 points is enough to graph a parabola? I mean, that's a pretty darn accurate parabola if you ask me. So that is enough. I don't have to bother with that whole t-chart. You know, I don't have to then go, 3, 1, and then pick some other points because I already have 2 other points. So we don't have to do this when you have other points. The time that for a parabola or a V or whatever, the time that becomes critical is if I have a parabola that, say, never crosses the x-axis. So let's say I have a parabola that's down here. Well, now I might want to come up with at least another point on the parabola to guide me on how fat or skinny to make it. All right, so we still have to answer the x-intercept. So if I plug 0 in here, so if I'm going to 0 in here, so negative 3 squared is 9. So negative 4 times 9 plus 1, so that gives me negative 36 plus 1 equals negative 35. So my y-intercept is going to be 0, negative 35. So let's go back to our graph. Well, that kind of makes sense because do you see how slowly this is going down? So it's going to take a long time for that to reach that y-axis way down here. And that's it. Oh, yes, no, I'm sorry, that is it because we did flip it upside down. All right, so make sure, because it was negative, make sure you're starring that and you're like remembering, oh, whatever my normal graph is, I'm going to flip it upside down. So I want you to do this one after the video on your own before you come to class tomorrow. Let's go ahead and make this one negative as well. Let's change that one. So this should be negative. And think of that as like I want you to think of it as a negative 1 times x cubed plus 2. You know, it's the same thing, right? All right, so I want you to do those 3. We will talk about odd and even another time, but there's one more quick little thing I wanted to summarize for you.